Looking at example 4, we are now going to look at a pair of equations, linear equations, and decide are those lines parallel, perpendicular, or neither. Okay, so let's go ahead and review. Parallel lines have the same slope. Perpendicular lines have the opposite reciprocal slope. I know we've written this before, but those are things that you have to have memorized. And we will need the lines in slope-intercept form to decide. Okay, so let's go ahead and look at part A here. And so if we're looking at part A, we first need to define their slopes. So in the first equation, you can see that your slope is -3/4, and in the second, it is 4/3, okay? So we can see that, hey, those do have opposite signs, but they do have to have both in order to be perpendicular. They have to have opposite signs and be the reciprocal of each other, which it looks like they are reciprocals. So we can go ahead and conclude that these are going to be perpendicular. Okay, so go ahead and write that down for part A. These lines are perpendicular to each other. Okay, looking at part B, that last part of needing the lines in slope-intercept form. So take a look at the second equation. That is not in slope-intercept form. It is not solved for y. So we can go ahead and keep the first equation there, y equals 2x plus 3, but we do need to solve that second one. Okay, so if we're looking at solving it, we first need to add 8x to both sides. That's going to cancel out on the left and leave me with 4y equals 8x minus 4. Then we can look at getting 4y by itself. We need to divide every part of the equation, both sides, by 4. That leaves me with just a single y on the left, and then 8x over 4, that reduces down to 2x, and -4 divided by 4, that simplifies to -1. Okay. Now we can look at our two equations in slope-intercept form. You'll see those circled in red, and notice that both slopes are equal to 2. Those are the same, so our lines are parallel. Next, this one is different for a couple of different reasons. We're looking at equations of parallel and perpendicular lines with our horizontal and vertical lines. So the first step in this one that is different is that we're given 2 points. We're not given the equation, but we know that we can find the slope from 2 points, and that is by using our formula for that, which is m equals y2 minus y1 over x2 minus x1. So it doesn't matter which point that we start with, we just have to be consistent, okay? So if I start with the right one and I look at my y values and I take 6 minus 6, so they just happen to be the same in both of those points, then since I started with my point on the right, I have to stay consistent and start with that when I do my x2 and x1. So I'm starting then again on the right with 4 minus 2, and so I get a slope of 0 over 2, which 0 divided by 2 is 0. Okay, so whenever I go to look at that parallel line, I can see that my parallel line has the same slope. Okay, so parallel line is just going to have the same slope for this particular problem that we're looking at. Okay, if I go on to the next one, we need to think about what is significant about our slope here. Okay, so let's look at a picture. Looking at a graphical view of our given line, we see here that it is horizontal. Okay, so the horizontal line, we get a slope of 0 because if our y terms are the same on a horizontal, which they always will be, then that means we're going to end up with 0 in our numerator. So what's significant about our slope here is that m is equal to 0, and that is going to give us a horizontal line. Okay, moving on to the perpendicular, whenever we look at that one, okay, if I do the opposite reciprocal of 0 over 2, then I'm looking at a case where it's undefined, okay? We have 0 in our denominator, and I'm going to say, oh no, okay? Because we do not want 0 in our denominator. We can't divide by 0. That's a math no-no. So our slope is going to be undefined. Okay. So So you can see that I've drawn in a vertical line, because if I have something perpendicular to a horizontal, it's going to meet that at a 90-degree angle, which is our definition of perpendicular intersecting at a 90-degree angle. So it's going to be a vertical line. So our vertical lines are the ones that have slopes that are undefined, and if you notice, if we look at a couple of points that I just put on the line for us to look at, -4 and -4 vertical lines have the same x value, so that means whenever we are doing our x2 minus x1 up here, that's where that 0 comes from in the denominator, and so we have a slope that is undefined. The next thing we're going to look at is utilizing that point slope form. So we're going to use this a lot in writing equations of our lines, and something to look at is that this y and my x are always staying there. Those are the x and y in our linear equation. My y1 and x1, that is coming from the ordered pair that is given, x1 and y1. And then, of course, my slope is also going to be the slope that is given in the equation, or I might have to find that if we're dealing with 2 points. So using point slope form, we're going to use that whenever we're just given 2 points to write an equation from, or if we're given a point and a slope. Okay, so let's look at example 5. So we're finding the equation of a line perpendicular to y equals 3/5 x plus 8 and passes through the point. So here we have a point, and we also have a slope from our given line, since this is the line that it's perpendicular to. Okay, and we need to write the answer in slope-intercept form. Well, I want you to notice that this is the line perpendicular to. Okay, so if our given line, what is our given slope, okay, from our given line? If we look at that, our given line slope is going to be m is equal to 3/5. So if our given line slope was that 3/5, then our line perpendicular is going to have a slope of -5/3 and going through the point 3, -1. So now we have that point and slope, and we can go ahead and write that in point slope form. When we plug this into point slope form using our 3 and -1 as our x1, y1, we get y minus -1, and it's fine if you write it like that, but I really want you to start thinking about anytime you think minus a negative, that's really plus, which you'll see in the next step, okay? That way we don't get confused with our sign errors and our parentheses. Let's just automatically think minus a negative, that's plus. So y minus -1 equals filling in -5/3 for m, and then times the quantity x minus 3, where we're filling in 3 for x1. Okay, so in step 2, just like we said before, minus a negative is really plus. Let's get used to just going ahead and writing it like that. Y plus 1 equals -5/3 x plus 5. Now we see that our original example said write the answer in slope-intercept form, so we need to go ahead and minus 1 from both sides, because that's going to cancel out our 1's over here, and we're left with our final answer is y equals -5/3 x plus 4. Okay? I also want to point out that if they would have asked us for this in point slope form, what is the equation in point slope form, we would just stop here at this second step. Okay, so we would need to simplify that minus a negative. However, we would not be distributing anything or solving for y. Okay, and that's only if they want your answer in point slope form. Otherwise, we need to read our directions, and if it's in slope intercept form like this one, we need to solve it for y. Okay, this is our last example that we will do together. And so let's go ahead and look at example 7. We have been doing a lot of perpendicular together, so we're going to take a look at this one. it gives us that line A is parallel to line B, and line A passes through the points -5, -5, and -1, -1. Okay, so this is where we need to start, right? Because we can't do anything until we utilize those points to find the slope, because these parallel and perpendicular lines are related to each other in terms of their slope, okay? So we have 2 points. We can find the slope of that. We know that m is equal to y2 minus y1 over x2 minus x1, okay? And so in this case, it doesn't matter which one I start with, I just have to stay consistent. Okay, I'm going to start with the one on the right. So if I start with -1 for my y, 2 is subtracting -5, okay, from the first set of points. And then I have my x1 and x2 to look at. So x2, I'm going to use -1 going back here to where I started with, and subtracting again a -5, they happen to be the same in this one, from my x1. Okay? And so whenever I do this, remember we're always thinking that it's minus and negative, that's a positive, so -1, that's really +5, and -1 +5. So we end up with 4 over 4, which means our slope is 1. Okay? But that is the slope for line A. Okay? That is what was given to us. We, however, need to find line B. So if I look at line B is parallel. Okay, and what does parallel mean? It means that it's going to have the same slope. Okay, so line B is parallel, that means it has the same slope, so its m is also 1, okay, and we're using the point -2 and 3. Okay, so we have a point and a slope. That tells me I'm going to use my point slope form, so that's y minus y1, which is 3, equals m is 1 times x minus x1, minus a -2, that is +2. Okay, remember this is our point slope form. If it asked for that, we could leave it there. However, we are required to do it in slope intercept form, so we need to solve for y. Okay, so I'm going to add 3 to both sides after I distribute. So we have y minus 3 equals, that just turns into x plus 2 when I multiply 1 times the quantity. And then adding 3 to both sides, I end up with y is equal to x plus 5, and that is our final answer. Okay, so go ahead and try the perpendicular one on your own. Example 8, remember that line B for that one is going to have the opposite reciprocal slope that you find in line A with those first 2 points that are given. Okay, have a great day.